Absolute value questions often look easy on the surface, but the SAT loves to hide subtle traps in the wording and in the algebra. If you're not careful, you can lose easy points in seconds. Let's make sure you never lose points on these. In math, absolute value means distance from zero on the number line. That distance is never negative, so an absolute value expression is always zero or positive. We write it with vertical bars around the quantity inside. Think of it as a size measurement, not a direction. This is why the SAT tests absolute value so often. It checks whether you understand distance, symmetry, and the idea of splitting into cases. When you're solving for x, you're really asking what inputs make the distance from 0 equal to the number on the right side. That framing helps you avoid mixing up signs and helps you see why two answers often appear. Here is the simplest example. The absolute value of x equals 5 means x is exactly 5 units away from 0. So you get two solutions, x equals 5 or x equals negative 5. Both are 5 units from 0. You can draw them on a number line and see the symmetry around 0. That is the mental picture you should keep every time you see vertical bars. Now let us look at a medium step up. The absolute value of 2x minus 3 equals 7. You split into two cases because the expression inside could be positive or negative, but after you take absolute value, the result is 7. Case 1, 2x minus 3 equals 7, so 2x equals 10 and x equals 5. Case 2, 2x minus 3 equals negative 7, so 2x equals negative 4 and x equals negative 2. Plug both back into the original equation to confirm they work. That is a good habit on the SAT, and it catches sign errors. If the equation is slightly more complicated, nothing changes about the rule. You still need the absolute value alone before you split. You still solve two linear equations. You still check both answers if the problem gives you time. On a timed section, that discipline saves you from silly arithmetic slips that cost real points. For a harder SAT-style problem, start with the absolute value of 3x plus 1 minus 4 equals 8. First, isolate the absolute value by adding 4 to both sides. That gives the absolute value of 3x plus 1 equals 12. Case 1, 3x plus 1 equals 12, so 3x equals 11 and x equals 11 thirds. Case 2, 3x plus 1 equals negative 12, so 3x equals negative 13 and x equals negative 13 thirds. Check both solutions if you have time. The algebra is the same pattern every time. Here's a common mistake. Students jump into cases before isolating the absolute value. They can create fake equations that look solvable, but are not. Always simplify until the absolute value stands alone on one side. For example, if the absolute value of x minus 2 plus 3 equals 1, subtract 3 from both sides first. You get the absolute value of x minus 2 equals negative 2. That is impossible, because an absolute value cannot equal a negative number. So there is no solution. Do not waste minutes chasing imaginary cases. Here is a fast SAT pro tip. When a question asks how many solutions the equation absolute value of an expression equals k has, think about k first. If a k is greater than 0, you usually get two distinct solutions. If k equals 0, you get exactly one solution, because the expression inside must be 0. If k is less than 0, you get 0 solutions, because absolute value is never negative. Use this as a quick sanity check before you grind through every case. It also helps on multiple choice when the answer choices list 0, 1, or 2 solutions. Let us recap 3 key ideas. First, always isolate the absolute value before you split into cases. Second, when the right side is positive, set up 2 linear equations and check your answers. Third, use the sign of key to answer how many solutions exist without doing all the algebra. Practice more on NovaMaths.